Okay, welcome back. This is Will Bastas. I take a little break, get organized, and what I'd like to do is show you some of those concepts that I talked about using the clay that also use forged steel. And the forge I'm going to use to get the steel hot today is, unlike the atmospheric Venturi burner that forge that I showed in the last videos. I want to demonstrate, just because I want to show everybody everything that I've, all the nuances of all the tools. There will be a time when I need a more powerful forge, and that more powerful forge is this one. And I'll pull the bricks apart to show you what is going on with this forge. So this has a chamber that I decided on the dimensions of it. It's basically 12 by 8 by about 10. So 12 deep, 8 wide, 10 inches tall. And it's a little bit bigger than the atmospheric forge because it's got quite a bit more power. And so this is the forge, the ribbon burner design that comes out of the Anvil's Ring. I believe it was winter 2003, I'm not really sure, but you can look at that online. And it's a pretty straightforward tutorial how to make that ribbon burner. You can look underneath and you can see how what the ribbon is comprised of. It's basically casting a Mizzou hot face onto a box, and then with about, I don't know, 20 candles that you embed in that Mizzou, and then when you burn it out, then you got all of these different voids. So that connects to a plenum, and the plenum has a little baffle on the other side of that 2-inch Schedule 40, so that the baffle is basically a washer, and it causes the airflow and gas to spread out so that it hits all of those holes. We've got 90 degrees here just because out of convenience, otherwise your whole mechanism would be up here. And I built it around, this blower is about $100. And it's not a bad blower, actually. I don't have a lot of time on that yet, but I'm getting there. And what I've done is I've got the blower, and you can baffle the blower. I run the blower wide open, so it goes up to the 2-inch pipe. And then here's where I choke it off. Is I made this choke just like the Hans Piot forge design, where it will choke off that inside of that pipe. So I can choke it off completely, or I can open it up. And I've got arrows where, kind of like the mixture. So there's your air, and the air comes up, and then it's introduced to the gas. The gas, I don't believe I put an orifice on that. An orifice will develop some pressure, in other words, on the end of that. I think it's just 1/8 inch pipe going into that at an angle. This really needs to be a needle valve. It's a ball valve. The ball valve works, but it's just not minute enough to get fine adjustments, but it works for gross adjustments. So you got your gas coming in here, and this is a normally closed 110 volt valve. And then when I turn the switch on, that opens up to give me gas. I've got this hooked up into this junction box, so that here's my fan controller. So when I turn this on, it turns the fan on, turns the fan controller on, and it turns the gas on all at once. So this burner, I could strike with a striker, but I'd probably put a piece of like burning cloth in there, burning paper in there to get it started. So, so just wanted to show you the controls. So you got your fan speed that I can increase or decrease, and the more air you put into the chamber, the more it has to exit. So keep that in mind, because you'll have what's called the tail of the dragon coming out here, and it'll make it difficult to forge around. So you may want to play around with how much air you put in there. You can play around with here, but here I find that it will bog down your motor. So I think that it's important to have that open. And although this is choked here, it's got a pipe that's open up here. And so if you can, there's a pipe right there. And so when I choke this down, what happens is that the air exits out of that pipe, and that pipe comes in here in that area, and it keeps everything cool anyway. So that way I can have the air going into the chamber, or I can choke it and I can have it coming out of the chamber without bogging down, putting a lot of undue stress on that blower. Okay, so this is built very similarly. I've got this holder here so that I can keep the bricks from falling off, and I keep them against the chamber itself. Now, the chamber has, this is your hot face. So it's when you've got something in here that's 2,000 degrees, then your hot face is where the outside atmosphere meets the inside atmosphere. And this I consider kind of a consumable. So you'll see this get hot, but it takes a long time for them to grade. So but I'm prepared to be able to like replace my hot face. So I think it's important to have fire bricks to be able to like adjust your opening, and so it's hands free, and I can just adjust my opening with a pair of monkey hands, really. So to get the forge going, I'm gonna strike a Mexican matches the best. I'll strike a piece of paper, a little bit bigger piece of paper. Now this will auto ignite like the other forge design once my chamber is hot. But you'll see, it's hopefully the paper, unless it's real paper, copy paper, it doesn't burn too well. Now the blower will get, it's a little unnerving. All right, so what we have is the option on a ribbon burner to go rich. So rich is when I've got a lot of flame coming out. See the flame coming out. I can also go leaner, where you hardly have any air. But ideally what you want is you want a little bit of flame coming out. Now, not too much flame coming out, not too much air pushing that flame out. If there's a lot of air pushing that flame out, then it's going to get your steel hot. So you want the heat inside the chamber. So what I do is I'll adjust it so that it's got more gas, less gas, and I like to hear that roar. So right about there, and I've got index marks so that I can remember where I had it set up the previous time. So we can let it get hot, closing up the chamber, and I think it's important that every turn that you go, whether it's a ribbon burner or whether it's a Venturi, have a chimney. And so this is the chimney for the ribbon burner, and it goes up into my hood, which is carbon monoxide, any volatiles will bring in the materials. So this is my chimney on my atmospheric, and this is my chimney on the ribbon burner. Actually, you can see a flame coming up from that chimney. So if you have a chimney on your forge, then it keeps the dragon's breath at a minimum. When you have your forge set just right, you have less dragon breath, you've got the heat that you want in the chamber. And I can also use that chimney for tempering tools, and I've done that before. I'll set up a little platform on that, and then that's a much gentler heat. In fact, you can put a hot plate on that, you can heat tacos, burritos, nachos. So nothing is wasted on the forge. You can also close off your chimney, but I feel like a chimney is really important to reduce that drag and thread. Now you can see a little bit of drag and thread, and I'm going to back that off by backing off the amount of oxygen, backing off a little bit of the. So when initially the flame is going to be heating the chamber, and once the chamber is hot, then the chamber is heating the steel, and the flame is also backing that up. The chamber is made out of, it's 2300 KOL all the way around the chamber, but to avoid having like a exposure, thank you, to that KOL. I don't really like KOL because KOL can break off into small particles at 2200 degrees. It undergoes this process called crystallization. So the once flexible fibers of the KOL is basically kaolin clay that's been superheated to over 3000 degrees and spun like cotton candy. And if you keep it within the temperature range, and this is 8-pound density, 2300 KOL, then it's pretty safe. But once you exceed, then the fibers become brittle, and then when they get disturbed, they break. And when they break, they become airborne. And those fibers are breathed in. When you breathe in the fibers of KOL, then it embeds itself in your lungs. And you wind up with cysts in your lungs, which is a very bad situation. So as much as you can, what you want to do is you want to avoid, it's the best insulation there is. It's very light, it's very fast. There's hard refractory and there's soft refractory. KOL is the soft refractory. Soft refractory, it reflects heat, light and heat, doesn't absorb it. Hard refractory absorbs the heat, and then once it's saturated, then it produces the residual that you're pouring into in the form of this energy into heat. The energy that's created from the ignition of your hydrocarbon, your gas, and your air. So initially you're heating the chamber. Subsequently, you're heating, the chamber's heating your steel with the addition of the flame that's coming off of the burner. So protect yourself from KOL or any loose refractory, powdered refractory, or airborne refractory, just because it's dangerous to lungs and lung tissue, that kind of thing. So the chamber itself is 2 inches of KOL, 2-inch thick. And then I pour Mizzou castable in there. It's rated at 3000 degrees, and the Mizzou has a much harder, durable surface. I pull the Mizzou up on the sides, and it kind of burns the sides, so it's radius. So it's a flat hearth. That Mizzou comes up, and then I rigidize the rest of the chamber. The chamber is rigidized. Now I use ITC zirconium sand on what is left of the KOL. It's called ITC, International Technical Coatings. You can get the utmost performance from the fuel if it is reflected back as light and heat back into your workpiece. So anyway, that's the idea behind this. I want a little bit more gas. There we go. That's about right. A little bit of flame coming out. Not so much that you're going to burn the hairs off of your hand. And if you put too much fuel in there, the chamber's gonna be colder. If you put too much air in there, it's gonna cool off the chamber. So it really needs to be a balance between just enough air and fuel to get the heat that you want. Okay. So I'm gonna work these bars by hand. I'm gonna work these bars out of the power hammers to illustrate this concept of the selection of the shape of the face of the tool in order to get what ultimately is the shape that you want. So these are not sophisticated shapes. It's basically it's the fundamentals and the rudimentary shapes. In future videos, I'd like to make things, but first I'd like to make sure that we explore the fundamentals, the concepts of heating, of holding, and the hitting. Okay. So I'll begin, and I'll forge 2 irons in the fire. And I feel more comfortable forging 2 irons in the fire than more than that. I'll put another brick on there so that I get the dragon's breath. Put a brick on there. That way it'll keep the steel cool. It'll keep the steel on the forge, and I'll get more efficiency out of it. It's not going to play along with it. Okay. So while it's getting hot, what I want to do is I want to show you. So what I did was I forged with these 2 hammers. I forged with the round face and I forged with the square face. What I want to talk about now, again, this out of the way, I'm going to touch my arm so I can stand right at the anvil. Oh, that's better. If you put it on a stump, make sure the stump is squared off so you get close to your anvil like this. You want make sure though that you're not directly over your anvil, so that if you have an errant hammer though, you don't want a hammer come up into your face. And I've seen that before. So if that hammer comes up, it comes off to the side. Not close to my ear, it's quite a bit of distance. So, but the closer you are to your anvil, the less you have to bend over. So it's important to stand up straight. If you're bent over, you're not going to be able to get as much of a hammer blow because you're that farther down. So look at how much more hammer blow I get when I'm standing up straight. This good posture anyway. So I'm going to forge this back to my bar shape. And if you're going to collapse the bar, it's easier to collapse round than it is square. Round doesn't have much surface tension holding it into the round. So if you're making flat bar, start with round stock. You can work with square stock, but the square stock is going to resist before it forges into the flat. All right, so I'm buying some time, and I'm betting my bar is hot. I don't want to cook it. If I cook it, I'll have to crack it. And also, when you overheat steel, you're going to lose steel, about 1 to 3% every time you heat it. You're also going to lose some carbon. That's called decarburization. You're also going to get some oxidation. So on your forge, hopefully you've got a way of controlling your atmosphere. And that's why I was talking about the dragon's breath and having to be able to adjust the volume or adjust the pressure and adjust the amount of fuel that's going in. So you can really dial in your forge and the minimum amount of oxidation. If you're getting a lot of oxidation, you don't have enough fuel in there. If it's too hot and you've got a good balance, then turn both of them down. So you got your air, you got your fuel. So if I'm getting oxidation and not enough heat, turn up your fuel. If I'm getting not enough heat, then there's just all those variables are in mind. So just keep that in mind. Okay, we need to talk about old monkey hands. We need to go to the new style monkey hands, because these are the ones I made in the last episode where you see you got 90 degrees. Talking about how important that 90 degrees was. Boy, do I have a heat. So it didn't take very long. When you have a forced air forge and you have the ability to have the hot face, the burner going across the forge like that, then it doesn't take very long at all to get hot. So I'm going to actually turn the forge down a little bit. Turn this down a little bit so I have less dragon's breath. Turn this down a little bit so I have a little bit more dragon's breath. And that should be about right as far as like how much heat I need in my chamber. So I need a conflict. Hold on to the steel here. Conflict on here. Pull it back. So what I want to do is I'm going to demonstrate that square hammer blow. The square hammer blow, what you're getting is, now it went down to about 1/4 of an inch, and I've got a crown here and I've got a crown here, not much on the corners, and really a lot of stretch this way. So if I wanted this to be rounder, then I need to go with a round face hammer, and that's the one I'm going to use next. So taking it down to about the same amount, you'll see that it's quite a bit more crowned. Let's take a look at what they look like. So the square face pulls the metal out perpendicular, but it also stretches it longer. See how much wider the shape is. Now, I want to do the same thing under the power hammer. So the power hammer is going to allow me to do a little larger stock. So I'm going to load these up underneath. My forge is now up to heat. It won't take very long. Not too much heat on that. Really important to maximize your fuel efficiency, and so I don't have to go through all that trouble as, you know, breaking it up and that kind of thing. But if I can run less fuel, get the more quality heat, more comfortable to me, it's not going to get the steel hot. It'll get the steel hot inside the chamber. Anything else is going to exit out of here. What's important is thinking about it from the start to the finish as far as the quality of your heat. So the next thing I'm going to do is I'm going to forge, while the 1 inch is heating, I'm going to forge this shape. So I'm going to show you the difference in how fast down to 1/4 inch and how much more efficient it is to use the peen of the hammer to spread that, and how much wider that shape will get. So I'm going to choose where that's going, and I need to have this brick on this so that I have that corner knocked out. And I'm going to do that. Press better. A lot of heat into that chamber to bring it back up to heat. Okay. Real-time heat adjustment. Now I'm going to go back and spread this using the peen. So this was forged with a square face because I could tell it's kind of weak as far as it being round. I'm going to, if I take this down to the same thickness with just the peen, you can see how much more efficient the peen is than spreading with the face. So this is spreading with the face, this is spreading with the peen. It's the same dimension. Now notice how the crown of that peen, it allows it to ramp off side to side so it doesn't dig in. So I'm at a 1/4 inch, roughly a 1/4 inch. Got about 25% more spread using the peen. So it's much more efficient if I want that metal to spread this way, use the peen, than it is to spread this way, using the face. Now, I'm going to spread it the opposite way. Spread it long ways. If I want the metal to flow the length of the bar, then I could work like this, which is not very ergonomic. It could also work like this. So going down now, same dimension, with a balanced hammer, you can see my fuller marks. You can see that it hasn't spread very much. Started off at 5/8, I'm at 7/8, but I've gone quite a bit further down, which meant that I got quite a bit of spread on that bar. So I can draw that out like this, or I can draw it out like this, which is a far more ergonomic. If you find that you're forging a lot, made this hammer. So this hammer gives me a straight peen, which is the straight to the handle, and it gives me a cross peen. So this hammer allows me to spread and lengthen. Spread. So I can spread, I can lengthen, and I can do it in the middle of a hammer blow if I need to. Now let's take a look at what the power hammer will do with those same kind of concepts. Going to use a square face like the square of the hammer, and then I'll use a round face. We'll take a look at the difference that we achieve. You might have seen that I had a little bit of trouble getting the hammer to rotate because I had the pitman set low to draw, and now I'm going to raise the pitman, and on the crosshead, you have to loosen the crosshead. And you can use the power of the hammer itself to bring it up on the crosshead. So now it'll forge more easily the tooling, but it won't hit the dies. So if I wanted to draw, I'll have to adjust it again. We'll talk about the difference between air hammers and mechanical hammers, but air hammers are superior. Mechanical hammers they're quaint and they have personality. So I'm not going to say one is better than the other, but sometimes if you want to get the job done, it's not a bad idea to invest in an air hammer. So we're back. I'm going to turn this on. I turned it off so that I could have auto ignition. I'm going to stand away from it while the blower gets going. And I've also got a longer tongue clip, so I had a tongue clip here. It didn't get much leverage. But since these were made out of rebar, there's quite a bit of positive pressure being put on this right now. I'm not even doing it, the tongue clip is, and these are springing, and so that is staying in place because of the spring of the rebar. This can be done with 4140, be done with 5160, 8620 rebar, and the best tongs are made out of material that when you squeeze them, they spring back, and that is super important in a pair of tongs. So what I want to do with this heat, I want to the same thickness of the material, I want to spread it one way and I'm going to spread it the opposite way. And I want to show you that it all depends on the shape of the tool. When it's done with the power hammer, it's a lot easier to see how dramatic the material moves. So I've got my tool, let's see, here. I put a 45 bend on it. It's a little bit more convenient. So I can run lengthwise on the material like this, and I can run widthwise on it like this. So first I'll isolate in the middle, and I'm going to run it lengthwise and draw it out to about 1/4 of an inch. You can see it widened from 1 inch to about 1 1/4 inches down to 1 inch. Now let's do the same thing, but I'm going to operate the tool like this. Now it's important that when you're using tooling, try to work in the middle of the die. Also, try to make sure that your tool is level. Your hammer will communicate with you whether your tool is level or not. Let me put this back in the fire. Smaller tongue clip. So this is a preview of what I'll be doing. Just like the peen of a hammer. So it's hitting here, it's falling off there, and it's falling off there. Make sure your handles aren't such that they encourage you to put your fingers in it, because when I'm flipping the stock, and it's important to work on both sides of the stock, that way you have symmetrical forging, your fingers could get hung up in there. And so I make this a very clip and route handle shape so that it fits in the palm of the hand, and it gives you orientation, but it doesn't allow you to get your fingers caught into the tool. So this will be the last thing I'll show today, because mainly I'm talking about the selection of the hammer to get the effect that you want, and it's important not to move the metal in the direction that you don't want it to go. Otherwise, you're kind of fighting yourself. So I'm going to take this down to 1/4 of an inch, and I've isolated the shape on the end. Let's see what I do with my tool. There it is. Again, working in the middle of the dies. I put myself a little flat there, so it's to the same dimension, but orienting the tool perpendicular, you can see that I got quite a bit much more spread. Now this has got a fan tail because there's surface tension that's holding that steel from spreading, that's still connected to it, but there's no surface tension at the end. So it'll give you a fantail shape like that, unless I were to fuller this to begin with to release that surface tension and allow that metal to spread. But basically, this is all I wanted to show you today anyway. Working the stock this way to the same dimension moves the metal in this direction. Perpendicular to that, it moves it in the opposite direction. So I've gone from 1 inch to 1.25 inches to 2 inches. So it doubled the width by working perpendicular as if it's a beam. So bottom line is, I just want people to think about how you're heating, how you're holding, make sure you have good control over your steel, and how you're hitting, and how you're developing power, but the nuances of the faces that you're using. And we talked about clay earlier and the specific type of clay. And if you look at steel like clay, and it is very similar to it with the kind of power that we're developing, whether it's by hand or with the power hammer, then you can anticipate the direction that the metal is moving. This is slow going at first. These are baby steps, but I think that the fundamentals are really important to build on. So we'll go further and further beyond this, but without these, I just have to assume that you know what I'm talking about. But now that we've got this covered, we're forming a foundation, a baseline. Thank you for your attention.